Good morning. Welcome back. So, last class we did queues, we did the lab program also, and then different variations of queues as well as applications of queues. Now, we'll do the next data structure, which is linked lists. Fine. So, list, as the name suggests, what is it? List is nothing but a list of items. Like you need to have a list of items. It can be, example, a list of student marks or pertaining to one student, or it can be of different students, or in a day to day life you need to buy a list of items, then you will have a list which contains different items you need to buy. So arrays also you can store. How can you store it? You can store it in an array. Arrays are probably the most common data structure used to store a collection of elements. Fine. So it's more convenient and accessibility is also easy by giving the index value or by giving the index number. Accessing also is easy, right? So, but then when you don't know how many you need to, for example, I have a departmental store and then I need to store the receipt numbers. I'm storing only the receipt numbers of people who bought a certain product. So by that receipt number, I'll get all the information. So I'm not keeping the information of the all the details of the people, but then I need to store the receipt number only of all the people who bought a certain product. But beginning of the day, I will not know how many people would buy that product through the entire day. So if I store it as an array, I need to have a guess and guess on the higher side only, because I cannot resize the array during the once I have a size of the array, I cannot resize it, right? So I need to say like around 1000. If I have an fixed size of the array as 1000, then it can increase or it can decrease. Like I can have, I mean to say, I can have more than 1000 people also buying that, or less than 1000 also buying that. But if suppose one or two buy that and I have around an array size of 1000, so I would be wasting that much memory, because I'll always like keep it on a higher side only, so that I will have the maximum or exceeding the maximum only I'll keep. Like if I feel that around 800 people would buy, I would say 1000. So there also I would be to begin with only wasting some 200 memory spaces. Like it depends on the data type, that many bytes of memory I would be wasting. But then suppose it's very less, like one or two buy or nobody buys that product, or one or two buy, or I can say 100 people buy, I would be wasting that memory, and it cannot be reused by any other element, because I cannot change that. Once it happens, it happens. That is, it is fixed or allocated during compile time before execution, because arrays are static allocation of memory. So I cannot change it. But then if you have something wherein you can resize it during runtime, like for example, I create a that time you have linked lists into picture. Like every time you need to add an element, you allocate memory to it, and then we don't use it, then you deallocate memory so that it can be reused or it can be used by something else. And one more thing about arrays is arrays are continuous memory locations. That is, it is stored one after the another, and they are physically next to one another, stored in an array. And array name always is a constant pointer to the memory address of the first element, that is a of 0. For example, a is the array, then a would be pointing to the a of 0th location. It would be a constant pointer there. Since it is stored in consecutive memory locations, you can easily retrieve it, and direct retrieval is also possible by using the index value. Whereas in a linked list, what happens is it is logically linked to one another, because to begin with, I don't know how many. Like for example, I start with, like I have a per customer buying, so I will create a node. In linked list, data items are called nodes. A node will have two parts. One is the information part, that is the actual information, wherein the receipt number I will store here, and in this example the receipt number I will store here, and the link part would point to the next. It would contain a pointer. It's a pointer to the next node in the list. That is, the link part will have the address of the next node in the list. They are logically linked to one another. They are not continuous memory locations. That is, I create it now, then again after some time new another customer comes and buys, I'll create another node. That is, creating is allocating memory dynamically during runtime, and then I would attach the link part. That is, I will make the link part of the first node point to the second node. Like that, wherever memory, when you allocate dynamically, wherever that memory is available, that would be allocated. They will not be one next to another. For example, the memory address of the first node is 100. The memory of the address of the second node can be 1000 also. Like, you don't know where that memory would be available. They need not be available next to 100 only. But then the link part of this node will have the address of that one. So logically they are linked and it forms a list. Getting it? So this is little difficult, but then please pay attention. It's not that difficult also. In a linked list is a linear collection of data elements whose order is not given by their physical placement in memory. That is what I said. They are logically linked to one another. It will not be continuous memory locations one next to another. Why is that? Because I don't allocate memory for all the nodes at the same time. Like in array size, I will say like 100 elements would be allocated at the compile time. So it would be that many blocks, 100 elements, that many bytes, one block of memory, which will be continuous to one another. Whereas here, as and when I need to add a new element, I allocate memory. So wherever, from where is the memory allocated from? The free pool, right? So wherever memory is available, from there the memory would be allocated. It's not like it need to be present next to the first node only. So a linked list is a collection of data items whose order is not given there by their physical placement in memory. Instead, each element points to the next. Points means in the link part I will have a pointer only. It's a structure. Node would be a structure because it's a heterogeneous data. The information part would have the information part, and the link part would be having a pointer which points to the next node in the list. When I say points, it will have the memory, it will point to the memory address of the next node in the list. So instead, each element points to the next. That is, it is a data structure consisting of collection of nodes. Yeah, what is each one called? It's called a node, which will have two parts. One is the information part and other one is the link part. Information part, whatever the user wants to store would be there. Like for example, in the example I gave you, the receipt number would be there, and then for each customer buying, I will create one node. So the second customer comes and buys, I will create a node and insert the receipt number in the information part, wherein the link part of the second would be pointing to null, because the last node link part will point to null. When the link part of the node points to null, it means that it is the last node in the list. Otherwise, each node would point to the next node. You can see node 1 is pointing to node 2 and node 2 is pointing to node 3, and the link part of node 3 is null because it's not pointing to anything. When I have a new node, then I will make the node 3's link point to the new node, and the link part of the new node would point to null. Getting it? And then how do I say this is the first node in my list? You will have a pointer called the start or the head. So whenever I write, I will use it as head only. It will start or head is a pointer which points to the first node in the list. Okay, they are also of the type node only. And then, so what does it do? It's a collection of nodes together represent a sequence. Yes, it does represent a sequence. Even though they may not be next to one another, I can hop from one node to another. Like node 1, I can traverse from one node to another using the link path, right? The link path would point to the next node, from there to the next. So it nodes together would represent a sequence. It is the most basic form wherein each node contains a data and a reference or a link part. Getting it? The data would be the information part would contain the data, and the link part or reference would contain the next node in the sequence. This structure allows for efficient insertion or removal of elements from any position in the sequence during the iteration. You can insert, you can delete, you can do that. Getting it? More complex, they are more complex. This is like there are different variations of a linked list. Getting it? Linked lists are among the simplest and most common data structures. They can be used to implement other data structures like other abstract data types are stacks, queues, associative arrays. You can implement. Yeah, when we did array link this one, what is that? Stacks and queues. We said you can have linked list based implementation or the dynamic implementation wherein the memory is allocated during runtime, or I said you can have the static allocation using arrays. We did array based implementation. We can also use linked list to implement several other abstract data types like stacks, queues, etc. The principal benefit or the main benefit of a linked list over an array is the list of elements can be easily inserted or removed without reallocation or reorganization of the entire structure of data. Like, what do you mean by that? For example, if I have to delete an element, we did that a deletion of an element in an array or insertion of an element in an array at a given position. For example, I need to insert an element at position 2 in an array, then I need to push the elements present in 2 to 3, 3 to 4, 4 to 5, then only I can insert. Same way, if I have to delete an element at 2, then I need to make the element at 3 go to 2 and 4 to 3, like that. But here what I need to do, I need to make the link part of node 1 point to node 3 instead of node 2. So I can take that out, right? And if I have to insert a new node between node 1 and node 2, make the link part of node 1 point to that new node and that new node point to node 2. That's what you need to do. Just you need to change the link part wherein it will point to a different node. It's more easier when compared to arrays. Getting it? Linked list allows the insertion and removal of nodes at any point on the list, like you can have at the beginning, at the end, or at a given location. Only thing is you need to change the link part, link part pointing. That's all. Okay. So this is about the linked list. I want you to go through this once. So now I'll tell you like a linked list, the definition. A linked list is a linear collection of nodes. Yes, it's a collection of nodes because each element here is a node. Element stored is in a node. So a linked list is a linear collection of nodes. Each node is divided into two parts. The first part contains the information of the element. That is called the information part, which contains the data for the node. And the second part contains the address of the next node in the list. That is the link part, which gives the memory address of the next node in the list. Getting it? And the first part contains the information, the second part contains the link part, which contains the address of the next node in the list. Then what are the different operations I can do? The different operation possible on a list are creating a linked list, yes. Traversing a linked list. What do you mean by traversing? Moving from one node to another, like visiting each node once is nothing but the traversal operation. Traversing a linked list. Inserting an item into the linked list, yes. Deleting an item from the linked list. Searching for it for an element in the list and merging two linked lists. All these are some of the operations performed on a linked list. Getting it? Then there are different types of linked list. They are single linked list, doubly linked list, single circular linked list, and doubly circular linked list. See, when I say single linked list, that I can traverse in one direction from the first node to the last node. I cannot do it in the reverse direction. Single doubly linked list. Why I cannot do that in the reverse direction? Can you tell me? See, here I can traverse from node 1 to node 2, from node 2 to node 3. Start, because start or head would point to the first node. In a single linked list, I can traverse from node 1 to node 2 to node 3. If I want to traverse in the opposite direction, I say it is not possible. Why is it? Because the link part here stores the information of the next node in the list. You don't have any pointer to the previous node in the list, and like arrays, it is not continuous memory locations. That is, it is not stored one next to another. They are not continuous memory locations where I say that okay, I can traverse back and forth. I can only do from one, like to the first node to the last node. I can do from the last. Here I cannot go back to the first because I don't know where the first node is. The link part only stores the information or the address of the next node. It does not have the address of the previous node here in a single linked list. So I can traverse from only the first node to the next node in one direction only. You can see here, like I cannot go back to the last node, I cannot go back to the first node also here. Doubly linked list, single circular linked list, and doubly circular linked list. In doubly linked list, you will have two pointers. I'll show you that. Linear. In circular linked list, the last node is connected to the first node, so it acts as a circle. I showed you circular queue also. That is, instead of none, it would point to head, the first one. Whereas in a singly and doubly, both way it is like that. There's a difference between a singly linked list or single linked list and a doubly linked list. I will show you what it is. A singly linked list or a single linked list, what we would be doing for your syllabus would be single linked list. We will be doing the creation of a single linked list, insertion of an element in the beginning as the already I have a linked list maybe of 10 nodes and I want to add an element as the first node. That is, inserting element at the first node, anywhere in between or as the last. Same way, deletion of the first, the last, or anywhere in between. And a singly linked list contains two fields in each node, an information field and a link field. Yes, the information part would hold the data of that node, and the link part would hold the memory address, or it would be pointing to the memory address of the next node in the list. And there is only one link field in each node, and it will point to the next node. It will not be pointing to the previous node in the list, and this is called singly linked list. So you know that the first pointer, I can say I will be referring to this as a head. Head is a pointer which points to the first node in the list. So that would point here, and this is H is node 1. D is the information, like it has a character information, see head. So H is stored in the information part. Link part is pointing to the next node in the list, and then the next node, like that it is going to point, and the last node, the link part would be pointing to null. It will not be pointing to anything because there is no other nodes in the list at present. So that is the last point. How do I know which is the first node and the last node? The head would be pointing. Instead of first PTR, I will say here afterwards I will be referring it as head. Head is a pointer which points to the first node in the list. So wherever head is pointing to, that would be the first node, and the node's link part is null. Whichever node's link part is null, that is called the last node in the list, and all the other nodes point to one another. Getting it? So like that. Why is it that you need a pointer here? Because I won't declare the size at the beginning. As and when I need to insert a new element, I will dynamically allocate memory. How do I allocate? Using new and delete. During runtime, if you want to allocate memory dynamically, use new, and to deallocate or free that memory, and so that it can be reused, that is using delete. New and delete. When we did the pointers chapter, I told you how to dynamically allocate and deallocate memory. We did allocation in constructors and we did deallocation in destructors over there. So here the first pointer, or nothing but the head, in a singly linked list, the traversal happens only in one direction. You cannot go back to the reverse, as well as the last node cannot. I cannot go back to the first node from the last node, because it would be pointing to null. So the last node will not have the address of the first node, and each node would point to the next node in the list. So this is a singly linked list which has one information part and only one link part, which will contain two fields in each node. The link part and the information part together would form a node. Please have a look. Next is single circular linked list. See, this is a single linked list. The Q is the last node, and node pointer part is pointing to null. Here what am I doing? It is pointing to the first node. So circular, it forms a circle, that is after the last node you start from the first node. Here also the backward traversal is not available, like from 11 to like this third node to second node I cannot go, right? Because I have only one information part and one link part. Only the difference between that single linked list and single circular is the last node is connected to the first node. From the last I can go back to the first, but then from second, third I cannot. From second to first I cannot do, or first uh, like third to second I cannot do, because I have only the information of the next node in the list only. From this I cannot go back. Only the last node is connected to the first node instead of null. That is, the link field of the last node contains the memory address of the first node. Such a linked list is called a circular linked list. Circular singly linked list. How do you access every node from a given node? That is, see, how do you access that? For example, I am from 11, I can do that, because next node again it goes back to the first, so I can go back, like it forms a circle, I can go back. Whereas here every node cannot be accessible once I cross this node. Like second node is done, from the third I cannot go back to second, because the last node goes to null, points to link part points to null, I cannot go back. Whereas in a single linked list, I can say from third, fourth, fifth again to first and second, so I can access it that way. Next is doubly linked list. Can you see the difference here? In doubly linked list, there are two pointers. That is, one, each node is having two pointers and one information part. That is, the forward is what the doubly linked list has total three parts. One is the forward, which pointer contains the address of the next node. Yes. Back is a pointer which contains the address of the previous node, and then the information where the data is stored. So that is why it is called a doubly linked list wherein I can move in forward as well as backward directions. That is, forward is a pointer which contains the next node in the list. See here, I have the next node, whereas the backward will contain the information of the previous node. So the first nodes backward would be pointing to null because there are no nodes before that, and the last nodes forward would point to null because there are no nodes after that. Getting it? The first or the head points to the first node, then it will have one information part, one forward pointer, which total three parts. The forward points to the second, third, fourth, that kind. The next node in the list, backward points to the previous node in the list, and the information would contain the actual data. But the forward pointer of the last node would be pointing to null because there are no other nodes in the list. There is no next node. So the forward pointer of the last node would be pointing to null, and the back pointer of the first node would be pointing to null because there are no nodes before the first node. Getting it? Please have a look and go through this. The doubly circular linked list is the forward pointer of the last node is connected to the first node. You can have a look. The picture itself is self-explanatory. So this is the doubly circular linked list. Next is the operation on linked list. The operations that are performed are creating, traversing, inserting, deleting, searching, and merging. This is, the previous one. The different types of linked list and the operations of linked list are commonly asked question. From here, it would be a 3 marker. I would want you to make a note of this. The operations on a linked list, or the types of different types or the variations of a linked list, and the operation of a linked list is something which you need to note it down because it's a very commonly asked question. Please make a note of it. Okay, you've made a note. Next, we'll move on. Now, when I say node, I should specify like how the node will look. I need to first create a node. That is, I need to create a node by specifying the structure of the node. So nodes of a linked list has to be created by the following structure declaration. Right? You need to first create like what will your information part, what variable will you be storing it, and then what would be the link part. You need to specify it. So every linked list program, first you need to create the node by the following structure declaration. We have done structures. I have done in the review of C++, like structure is a heterogeneous data type of, that is it's a collection of elements of different data types. Like we did the student structure, the int registration number, char name, char address, and all that int dob, like we did that, right, wherein it is a collection of elements of different data types. The same way, first you need to specify what is this. You have to create a node by the following structure declaration. Struct is a keyword, node, struct node is the name of the structure node. Basically, struct is a keyword, and then within two flower brackets, and a structure has to be terminated by a semicolon. You can have star node 1, node 2 now or later, it doesn't matter. Like you can also like node 1, node 2, or I can say head and current pointer, basically of the type pointer of the type structure node. That is what I mean to say. Struct node. Node is a name, struct is a keyword. It has two elements because each node will have two elements in a singly linked list. One is the information, the other one is the link part. Here, int info means I'm going to store integers in the information part. That is the data type of the information part. Here I am saying is integer. That is I'm going to store integer elements, and then struct node star link. I'm creating a pointer because it's star link. So I'll tell you what it is. Let me say, for example, how do I create a integer pointer? Like how do I declare an integer pointer? So before that, let me say a structure. Struct is a keyword and node is the name of my node. Okay. And then I will say I can have char, int, float. Let me say float ele. Ele is going to store my information, and then struct star. I can say ptr, I can say link. Okay. So now you tell me, generally when I declare a pointer, I want to declare a pointer which points to a integer location. How do I do that? Which points to a memory location which holds an integer. That is what is the correct way. Like I want to create a pointer which points to a location which holds an integer data type. So I need to have an integer pointer. How do I say? Int, yes. Star, yes, I will say name of the pointer is ptr. So I'm creating a pointer ptr which points to a location which holds an integer value. So it's an integer pointer wherein it points to a location which holds an integer, right? That is int x. If I say int x and int star ptr is equal to ampersand x, so it points to location x, memory location of x, wherein x is a integer. The same way, if I want, because I said the link part, each node's link part is a pointer which points to the next node in the list. Fine, it should point to the next node. The data type of node is structure, right? Struct node of that type only, because that structure node will have float ele, and the structure of that I can have many nodes. Like I can have float ele. Here I have declared, if I say int ele, that is different than this, right? Because how many bytes would be allocated? It will be 4 bytes because it has a float string. So the next node in the list will point to a node of the same structure. So how do I create the link part? Like how do I create a pointer? Data type and the star and the name of the pointer. Like right, pointer name ptr I have given. Star means it is a pointer and it's an integer pointer, that is it points to a location which holds an integer. The same way, if I want to create a pointer which points to a node, how will I do that? It the data type struct, sorry, it's and then star is for pointer. I am giving the name as link. Right? This is how I do that. I declare. Getting it? Please have a look. Why? Because I'm stressing you should know why I wrote that statement there. Because the link part, the node's link part points to the next node in the list. So the data type, when you are creating a pointer in star ptr or char star ptr, whatever you are giving, that should that is, the PTR is a pointer which points to that location which holds an integer. Same way, I am pointing to a next node of the same structure, of the same type. That is why struct node, structure is a data type, we all know that. So struct node star link, link is the name of the pointer, and star because it's a pointer. So link would be pointing to the next node in the list. Hopefully you're getting this. In this, what is there in the above? In the other words, the structure pointing to the same type of structure. Yes, it is pointing to the same type of structure, because structure, that is, the node 2 will also have a float in an information part, or and a link part which points to the next node of the same type, right? So in other words, structures pointing to the same type of structures are self-referential in nature. Link is a pointer to a structure of type node. Hence, the structure node is a self-referential structure with link as a referencing pointer. Getting it? Please have a look. So, yeah, at least you have understood what is that struct node star link. It will point to the link part will point to the next node. So you're basically declaring a pointer here. That is how you do that. Here the info is the information field and link is the link field. And then the link field is the contains a pointer variable that refers the same node structure. That is what I told you. It will refer to the same node structure because next node will also have the same structure. Such a reference is called self-addressing pointer or self-referencing. That is what I told you, self-referential and self-addressing pointer, all that. So we have decided, like till now, what did we do? Linked list are each element or each stored in a node. A node will have two parts. One is the information or the data part, the other one is the link part. They will be logically linked to one another because they will be scattered in memory, not one next to another to arrays, like arrays. As and when you create a node, memory would be allocated dynamically. That is, you would be creating a node by dynamically allocating memory for that during runtime. So whenever you allocate, like whenever you create, wherever memory space is available, it will create that. So it will not be one next to another, it will be scattered everywhere. And then the link, so the node, each element is stored in a node in a linked list will have two parts. One is the information part and other one is the link part. The link part would be pointing to the next node in the list. Head is a pointer which points to the first node, and the link part of the last node would be pointing to null because there are no elements, like there are no more nodes in the list. The different variations are single linked list, circular single linked list, doubly linked list, and circular doubly linked list. Singular linked list is you will have on the node will have only two parts, the information part and the link part. Head would be pointing to that, and you can traverse in only one direction, that is first node to the last node, because I don't have a pointer which points to the previous node here and the last node. After that you cannot go back to the first node also, because the last node's link part would be pointing to null. In a circular singly linked list, the last node would be connected to the first node. So definitely you can go back, but backward traversal is not allowed. You have to complete the list, go back, and again you can traverse because it's a circular one. Whereas in a doubly linked list, it will have three parts, that is the back, the data, and the forward. The forward pointer would be pointing to the next node in the list, and the last node's forward pointer would be pointing to null because there are no nodes after that, and same way the back would be pointing to the previous node in the list, and the first node's back would be pointing to none, because since it being the first node, you since it being the first node, it will not backward pointer will not have anything, it will be pointing to null. And then in a this one circular doubly linked list, the last forward pointer of the last node is connected to the first node. Then before creating, you need to define, like, node creation has to be happened this way only, has to be created by the following structure declaration. Struct, this is the keyword to declare structures. Structure is nothing but heterogeneous collection of data, wherein the elements of the structure can have different data types. It's a collection of that under one name. Here the name of the structure is node, and then struct is a keyword. Int info, that is the info is the variable which will hold the information or the data of the information part. I can have int ele or float ele, anything. It's like, yeah, int this one. And the next is the link part. What does the link part do? The link part is a pointer which would be pointing to the next node in the list. So I showed you, like, if I create a float pointer, I will say float star ptr, wherein ptr is a pointer because star is there, pointing to the memory location which contains a float value. Like, I will say int float star f1, and then int float star ptr is equal to ampersand f1. So I can make ptr point to f1, which is a float variable, the memory address of that. Same way, if the link part is pointing to the next node in the list, so it is pointing to a node basically. So whatever it is pointing to, that data type has to be given. So struct node star link, and I am closing my structure. Node 1 and node 2 again are called structure variables, with the help of which I can access the elements of a structure. These are structure uh, pointer variables because I have a star over there. Here info is the information field and link is the link field. The link field contains a pointer variable that refers the same node structure. Yes, it points to the same node structure because the next node will also be same. You won't go on creating structures for each node, since such a reference is called self-addressing pointer. I want you to make a note of this. After this, when I say I will create a node during runtime, so what do you mean by that? During runtime, well, how do I create it? By using new. The operator new is used to allocate memory space during runtime. The new operator denotes a request for memory allocation on the free store. If sufficient memory is available, new operator initializes the memory and returns the address of the newly allocated and initialized memory to the pointer variable. That is what new does. That is, first of all, using new only you can allocate memory. Here int start, I have in the example, you can see int star tmp. Tmp is a pointer which points to a of type integer. TMP is equal to new is a keyword used for new is an operator used for dynamically allocating memory, and you need to pass the data type to it. For example, I have int of 5, that is I need to store 5 integers. Like, for example, integer is how many bytes? 2 bytes. If I take 2 bytes, then 10 bytes of memory should be allocated, and temp should be pointing to that because it's a pointer, right? That is what I mean to say. The new operator denotes a request for memory allocation on the free store. Free store is a memory space wherein the memory is allocated and deallocated. The memory is put back during runtime. In that, if sufficient memory is available, yes, because you may not have that much memory. For example, 10 bytes is not available, then it cannot allocate, right? So if sufficient memory is available, new operator initializes the memory and returns the address of the newly allocated and initialized memory to the pointer variable. Why is it pointer? Because pointer points to an memory location or an address, right? So that address would be assigned to temp. What does first line will say? I am creating a pointer. The second line is using new. I am allocating memory to store 5 integers during runtime. The syntax, please write it down. Or here I can also say that is int star ptr, or I can say int star temp is equal to new int of 5. That is declaration, and I can do it together like int star tmp is equal to new int of 5. I can do that also. Getting it? Please make a note. Then, how do you deallocate memory? What do you mean by deallocating memory? Deallocating is freeing the memory space. Like, I don't want that. I'm not using it anymore. I can free the memory space, which will go back to what? Free store, and then it can be reallocated again and reused. The memory can be reused. Delete is used for this. The syntax is given. Please have a look and make a note of it. The next is traversing a linked list. What is traversing? Traversing is a process of accessing each node of the linked list exactly once to perform some operation. You can also, like we did for arrays also, that is frequency of an element in an array. So I can say frequency of an element in a linked list also. Like I will be traversing a list, and the same way I'll be traversing an array, I'll be traversing a list here, right? Because I'm not creating a linked list here, I am traversing an already created linked list here. So traversing is a process of accessing each node of the linked list exactly once to perform some operation. So traversing exactly like is a process of accessing each node of the linked list once to perform operation. How do I traverse? I will tell you. Traversal, like first we will do how to create what is an empty node, how to first create a structure, then how does an empty node look, first new node creation, and then I need to check whether it is the first node in the list or there are any nodes in the list. If it is the first node, it is very easy, make the head point there, leave it. Otherwise you have to traverse the list till you reach the last node and make it point to the new node, and new node would link part would be pointing to none if you are attaching it as the last node to the last, or in a given location. What you have to do, you need to go back one position before and then put this there, and then this node's link part should point to the next. Like you need to create or break the chain there, point that here, and then this one I don't think so they'll ask you here. I'll just show you that in a program, but then you don't have that in your course. But beginning and end, yes, it is there. I will do the algorithm, but then when I will show you the program wherein you can insert a element at any given location also. So, traversing a list, what are the steps to be followed? To begin with, move to the first node. Yes, for traversing, you need to start from the first node. How do I say it's a first node? Because head is a pointer which points to the first node. Or I can say start or head. Some textbooks have given start, some have given head. It's not a keyword. Like I'll say this is a pointer which points to the first node, and always it would be pointing to the first node only. You don't use it for traversal. Traversal, I will use current pointer. I will make it point to first head, and then I will go on traversing from one node to another till the last node. So I can say make to begin with, move to the first node. Go to the first node, fetch the data from the node and perform the required operation depending on the data type. Like for example, I want to find the frequency of an element. So what should I do? I should you fetch the data. How do you fetch the data? I can access with the structure variable the information part that I can do, right? So fetch the data from the node and perform the required operation. Here I need to compare whether it's same or not if I want to find the frequency. So whatever operation you're doing, fetch the data, do it. Advance the pointer to the next node. Advance means move the pointer to the next node. So that I will tell you how to traverse, like exactly the link part of the current pointer. You have to go on current pointer is equal to link of the current pointer, which would be the next, wherein current pointer is used for traversal, and it will start from head, that is current pointer is equal to head, and then you go on traversing until the link of the current pointer is not null. Once it becomes null, it means that it is the last node in the list. So I'll tell you how it works on, I will type it out for you, but then I can traverse it this way. I will have two pointers, one pointer which is pointing to the first node, that is the head, and current pointer I for traversal I will use starting from the head. It goes on, I can move it from one node to another, that is advance the pointer to the next node. Then steps 2 and 3 is repeated. Yes, fetching, doing the operation, and then advancing it to the next node until all the nodes are visited. All the nodes, you start from the first node and you go on fetching the data, doing it, and then going to the next node. Like this you go on doing it until you go to the last node. Like last node means the link part of it would be pointing to null, then you stop. That is the traversal operation of a linked list. Please have a look and make a note of it. So hopefully you have understood that. In the next class we will, okay, you can have a traversal operation from here only. This algorithm traverses the linked list. Here start contains the address of the first node. P is a temporary pointer used to visit all the nodes from the beginning to the end of the list. Please make a note of the statement, and then what you are going to do, the first is I need to start from the first node. So which is the first node? Start contains the address of the first node, and P is also a pointer of the same time. What I will do is P is equal to start. So automatically P would be pointing to the first node, while P is not equal to null, because P will be only null only the when it reaches the last node, because the link part of that would be pointing to null. How do I process data? First you need to take in like P of info, P arrow info would get you that, and then P is equal to link of P. Link of P would be pointing to the next node. Like this only you go on doing it until the last node is encountered. We will again do this in the next class, and we will do the next class how to, we'll start with inserting a node in the beginning of the list at a given location and at the end of the list. Before that I will show you exactly how it works also. So I will just recap this again. Hopefully you have understood today's class. Take care, stay safe. See you tomorrow. Bye bye.